Now let us try to understand what happens when we want to delete an item at index I of an array of n elements. So again, in this left hand side, it shows the pseudocode for deleting an element. And if you have the knowledge of any programming language, you can try it out in your preferred editor. But here I am going to show you what actually happens in this pseudocode. So deletion means, again, as we have discussed in the previous video, we tried to connect this example with a real world example of organizing the table. So let's stick to the same example. Let's say again, in a room you have many tables. You have organized many tables in the row, so like this. And this is your table number 0, table number 1, then table number 2, and then let's say table number 3, and so on, something like this. And now let's say if you want to take this table to another place, so what are you going to do? So whenever you will remove this table and take it out, then there will be an empty place over here, so like this, after you took it out. So, and remember, as I have told, you have to make sure that all the tables or all the items in the new organization, in the new table, should occupy the contiguous location. So that means what? You have to fill out this empty space. So what you have to do is you have to move all the table in the right hand side. You have to left shift all the table in one place like this, and you have to do until the end. The same thing actually happen in an array also. So let's say this is my array. Let's say it has elements like 5, 31, 22, 96, something like that. So this is 0, index 0, index 1, index 2, index 3, like this. And then let's say I want to delete this element at index 1. So what do I need to do? First, whenever, if I just delete it like this, there is an empty space created. So what I have to do is, in order to guarantee this contiguous occupying of the elements, I have to start left shifting all the elements in this direction. So that means 22 should be moved one place left. So instead of here, it will come here now. And after that, 96 should also be moved to one place left. That means instead of here, 96 should be in here. And the size is now one less than the previous array. But now, as you can see, everything is again taking the contiguous memory location. So 0th element, 1 at the index 0, and element at index 1, element at index 2, everyone is occupying the contiguous memory location. And this left shift again makes the process very inefficient. And now we are going to understand how can another data structure called linked list can make this process more efficient, how it can eliminate the need for right shift or left shift, and make the process of insertion and deletion in a list more efficient considering to an array.